calculator. Okay, so here's the general situation we're given. We're given this information over here. We'll get to it as we go through. So we're trying to find the smallest n value possible. So let's start by finding a ratio between A and D here. Okay, we're going to start with the single slit. Let's just mark it single. So we can kind of see from the situation, like if we kind of draw up to the peak of this spot, what we get is basically a tangent situation, right? Because we know the length, we know this height, so what we can do is basically just establish the fact that tangent theta is this angle here, is equal to the opposite, which we're going to know is W, over the adjacent. Now, here's the key. The opposite, we're only actually using half of it because the line kind of cuts out here, so we're going to mark it as 1/2 W, right? So we can rewrite this as tangent theta is equal to W over 2L, and then to isolate W, we'll just bring 2L over. That's 2L tangent theta. Now, there's a weird little thing where if the angle is small, the tangent and sine are basically the same. So let's use that. W equals 2L sine theta. And now, you know that sine theta has an equivalence where it's m times lambda over A. And let's clean that up a bit. So we get W equals 2L m. In this case, we cut the m is just 1. Lambda A. W equals 2L lambda over A. Now let's look at the double. Double, same idea. Tangent theta is equal to the height. In this case, it's the whole thing times the same length. So then we could just isolate very easily with W equals L tan theta. Same idea. If it's infinitesimally small, it's basically just the same sign. So we get W equal L sine theta. And then we can translate that into W equals L m dot lambda over D. The idea, we're just going to use 1 for m. So what we get is W equals L lambda over D. Now because we know there's 8 bright spots, 8 dark spots, when we set them equal to each other, we're actually going to do 2L lambda over A equal to 8 lambda over D. Now we can cancel L lambda and 8 and 2, so what we left is 1 over A is equal to 4 over D. And that's also the same as saying D equals 4A. So we're going to save that. P. Now, okay, D equals 4A. Now let's try and figure out what A even is. We can do that looking at the diagram for the second part, the 2 slits, right? So we know that here to here is D. It doesn't cover the entire thing. What's left is on the bottom 1/2 A, and on the top also 1/2 A, which adds up to 1A. And then we know the whole thing, this whole space is 250 micrometers. So let's do it. Let's do 250 micrometers is equal to D plus 2 1/2 A, which it seems redundant, but I'm just going to keep track of it anyways. Let's use this equivalence of 4A equals D here. So that's 250 micrometers. is equal to 4a plus 1a. We can add those two up to get 250 microliters is equal to 5a. And we get a is equal to 50 microliters, or if you want to keep it in liters, just for the sake of keeping track of our units, a is equal to 5.0 times 10 to the negative fifth liters, right? Let's clear this up. Let's get that saved up top. A equals 5.0 times 10 to the negative fifth meters. Now, let's use that A to find the value of lambda, right? So recall from earlier that we had that equivalence, W equals 10 equals yeah, okay, so recall we have this equivalence. This one here, just had to derive it because I forgot. So W equals 2L. Remember that N is just 1, so we can just forget that. Lambda over A. Now we want to isolate lambda here, right? So let's isolate lambda. We're going to multiply A up top. We're going to divide 2L. So we get W dot A over 2L is equal to lambda. So we just plug in our numbers that we know. The width is 0.048 meters times 5 is 10 to the negative fifth meters, all over 2 times 2 meters, which we're given in meters, which is nice. So we have lambda equals, I'm not going to do that by hand, 0.048 times 5 times 10 to the power of negative 5 over 2 times 2. We get 0.000006, which is the same as 6.0 times 10 to the negative 7th meters. And that's why we do it in meters up here, so we don't have to convert later. So I'm going to save that as wavelength is equal to 6.0 times 10 to the negative 7th meters. Let's put it all together. So we know, just given the situation, right, the waves start at the same time. So there is no, so phi would just be 0, but there's a dark spot in the middle. This is in the prompt. Because there's a dark spot in the middle, there has to be some kind of phase difference. And then if they're flipped, that means the phase difference is pi, right? So then that means the phase difference would be pi. So why does that matter? We can use that to determine n, right? So, you know, delta is equal to pi. You know, pi. It's 1 minus 2. So now what do we do for this? Well, you know that these are equal to k del x plus phi, no, minus phi. Yeah, minus phi. No, plus phi. Minus k del x, k prime del x plus phi, but it doesn't matter because it's 0. So let's put in 2 pi over lambda for k del x plus 0 minus 2 pi over lambda prime del x plus 0. So what's lambda prime? Well, lambda prime is lambda over n, but because it's on the denominator, we put n over lambda, just for the sake of skipping around a bit. So we get pi equals 2 pi over lambda del x minus 2 pi over just lambda del x n. Now we can kind of take this out. So what we get is pi equals 2 pi over lambda del x 1 times n. Actually, let's just move this. I'm not going to bet down for this. We can move this over here, so what we get is lambda on top, pi lambda over 2 pi del x is equal to 1 minus n, and we know that pi's cancel out. Now we can subtract 1 over here. So what we're left with is lambda over 2 del x minus 1 is equal to negative n. Because we want our n to be positive, because that's our answer, we're just going to switch that over. So what we get is 1 minus lambda over 2 del x is equal to n. Now let's plug in our numbers. We know it's 1 minus lambda, which is 6.0 times 10 to the negative 7th meters over 2 dot 1.00 times 10 to the negative, oh, well, that's just 1 micrometer, okay, is equal to n. Now these cancel out nicely, so what we're left with is 1 minus 6 times 10 to the negative 7th over 2 times 10 to the negative 6th. What we're left with is a nice, clean n equals 7 over 10, and that is our smallest possible value of n.